We're going to add
All right. Hi, everybody. Mrs. Pesic here. We are recording section 12.3, sector area and arc length, and I'm live with block 8. Block 8, do you want to give a little shout out? All right. So our goals are to find the areas of sectors and to find arc lengths. Let's start with what is a sector. All right, a sector of a circle is a region that is bounded by two radii of the circle and the intercepted arc formed by the two radii. So a sector of a circle, in this case, if I kind of color this in a little bit here, I mean, it's already shaded, but we're talking about this region right here, right, that is filled in, all right? That's a portion of the entire circle. It's formed by two radii and the intercepted arc, all right? If you notice, we would name the sector ACB. We got to name it with these two endpoints of the arc and the center of the circle. So we can call it sector ACB. And the formula is really not that hard to remember. It is really just say, take the area of the circle, but multiply by the fraction of the circle that you want. All right, so in this case, we want what fraction of the circle? If this is m degrees here, then that would be m over 360, right? So that's the fraction of the circle that we want, and we multiply by the area of a circle, which you know that formula is pi r squared.
Is it, so you're going to get a decimal?
You're going to get a decimal? Is that what you're asking? Sure, decimal, because you got pi in there? Sure. Okay, so let's try these. Do you have these examples?
Yeah.
Okay, so let's try the first one. We want to find the area for each sector. If we want the sector area of sector MPN, again, that area formula is pi r squared times the fraction of the circle that we want, which in this particular case is going to be what fraction? Mitch? Okay, 80 over 360. And to find the area of the circle, I need to do pi times the radius squared. Rachel, what's the radius here? Oh, pop that back in there. Audrey? 3. So I get pi times 3 squared times 80 over 360, whatever that is. 8 over 36. Oh, by the way, look at the directions. It says give your answer in terms of pi and rounded to the nearest hundredth. So I'm just going to grab my calculator here. I would if it was turned on. We're getting there. As it's cooking here, I did have what, pi times 9 times 8 over 36. What did I do wrong?
It's 360, not 36.
I reduced 80 over 360.
Oh, sorry.
Did you notice that little sneaky thing I did?
No.
And so now I can say, hey, 9 goes into 9 once and into 36 4 times. Is that true?
Yeah.
And then 8 over 4 is really 2, so I don't even think I need my calculator. I'm getting a 2 pi. Does that look right?
Mm-hmm.
Are we okay with that?
Yeah.
Oh, we're doing it.
So 2 pi, what would be my units for this?
Inches squared?
Square inches, right? Because we're talking about the area of a sector, and area is expressed in terms of square inches, square units. So this would be 2 pi square inches. That would be the answer in terms of pi. And then if we want an answer rounded to the nearest hundredth, we can grab that calculator, and I can just do 2 pi on my calculator. 2 times pi is approximately 6.28, would be rounded to the nearest hundredth. Would you agree with that?
Yeah.
Okay. So my answer for this would be 2 pi inches squared, or 6.28 inches squared.
So is that just the length of arc MN? Like, I'm confused to what exactly you're saying.
That's not the length of an arc. We'll get to arc length in just a minute, but this is the area of this sector. That's how much space is being taken up by that sector.
Which one do you want
So-
to say?
we can find an area of an object with a curve.
We can. And we can, and you are. Okay, how about this one? We're doing this one here. We're trying to find the area of this sector. We drag this down here so we have a little bit more room. If we want to find the area of this sector, can you help me out with this? Olivia.
We do area equals pi r squared, and then parentheses, would it just be 120 over 360?
Okay. And what is the r for the radius?
6.
So we get pi times 6 squared times, I'm going to do my little trick again, 120, I can divide out those zeros, so I get 12 over 36, right? 12 over 36 is 1/3, so I get area equals pi times 6 squared is 36 times 1/3. So what is this answer going to be here, Nathan May? The 3 goes into 3 once, and into 36 how many times? Divide on your calculator. What's 36 divided by 3? 12. So I would get 12 pi. Agreed? And what units would this be? 12 pi what, Nate? Nate? Centimeters squared. All right. So 12 pi centimeters squared. Do we agree on this?
Yeah.
All right. Connor?
This is a stupid question, right?
Not at all.
It is, but,
Attention to all students who will be going to the track
for
meet today.
12 pi,
At this time, we have to
we want to do, when we multiply 12 times pi, it's like 37699. Can we just round that to 37?
So 12 pi is approximately 37.6991. So I would say 37.70. So our answer here should be 37.70 centimeters squared, right? Here's our answer in terms of pi. Here's our answer rounded to the nearest hundredth. Questions on this? Okie dokie, let's talk about a segment of a circle, which is different than a sector of a circle. A segment of a circle is going to be the region that is bounded by an arc and its chord. All right, region that's bounded by an arc. Here's an arc right here. Right there, there's an arc. And here would be the chord. So here's chord QR and here's arc QR. So that region that's in between is considered a segment. All right, a segment of our circle. All right. So the shaded region in this figure is a segment. All right, in order to find the area of a segment, we're going to need this formula, if you want to think of it this way. If I want to find the area of this segment right here, I'm going to have to find the area of a sector of the circle, but then subtract off the area of this triangle right here. So if I subtract off that, oh, that's interesting. If I subtract off that, if I subtract off this triangle area, then I'll be left with just this segment area. Are we good with this? Make sense? All right, we've done enough of these composite figures, hopefully, that you know that you can subtract off one area from another to get the remaining area. Okay, so let's try this example. We're going to try and find the area of segment ACB to the nearest hundred. And so what are our steps? Our steps are going to be, first of all, step 1 is to find the area of the sector. So if I want to find the area of the sector, I'm going to do that. And then I'm going to find the area of triangle ACB, and then I'm going to subtract. The area of the segment is going to be the area of the sector minus the area of the triangle. So help me out. How am I going to find the area of the sector here, Rachel?
7.5 pi 12 squared
pi times 12 squared, that's pi times the radius squared.
Times 60 over 360.
Yeah, they're telling us that this angle here is 60, but doesn't that mean that this arc measure is going to be 60 degrees as well? We learned that about central angles and their arcs. All right, so times 60
Yeah.
over
60 over 360.
over 360. Everybody agree with that? So we get pi times 144, and what's 60 over 360? 1/6. And so what do I get for this? 24 pi. Do people agree with that?
Yeah.
Yeah.
Inches
But I'm
squared.
giving you the answer.
All right, 24 pi inches squared.
To my defense, it doesn't say anything about putting in
Wait, I
the
was fine.
It doesn't, so we can convert that to a decimal. What's 24 pi as a decimal?
75.40.
75.40
Yes.
inches squared. Everybody okay with that?
Wait, I have a question. Can
Olivia?
I still do your like technique instead of doing 1/6? Can I just do the thing where I cross up the zeros?
You can, but then we can reduce 6 over 36 to 1 over
You
6.
don't have to, you can just plug it in the calculator.
Or you can put it all into the calculator in one fell swoop. All right, what about step 2? We're trying to find the area of triangle ACB. We're trying to find the area of that triangle. What do you notice about this triangle?
It's equal, right?
Well, both legs are gonna be 12
Hands,
inches.
please. What do you know about this triangle? Nathan?
Equal.
Will it be equiangular?
Yeah,
Will it be equilateral?
yeah.
Okay, well, all I know is that this angle is 12.
Oh, yes.
This side is 12, and this side's going to also have to be 12, agreed?
It's
Okay.
gonna be equal.
And this angle here is 60, right? You with me? So, side note, here's our triangle. All I know is this side is 12, this side is 12, and this angle is 60. You with me?
Yeah.
And I know, though, from the isosceles triangle theorem, oh yeah, I'm reaching back to first semester,
Grab that there.
grabbing it back, pulling it up. If two sides of a triangle are equal, then according to the isosceles triangle theorem, these two angles have to be what? Equal. So I know that this angle is congruent to this angle,
Yeah.
and that means if I'm already using 60, I've got 120 left to split. You with me? Yes, because the three angles have to add up to 180. So that means I can split 120 up evenly, but that means this one's going to be what? 60, and this one's going to be 60. So do I have an equiangular triangle? Yes, and all equiangular triangles are also equilateral, so this side is going to have to be 12 as well. Do you like our little proof? We didn't even do two columns. Does that make sense? All right, so going back, backing up. So if I want to find the area of this triangle, here's a little blow-up picture of that triangle, right? And we know it's a 60, 60, 60, 60, and we know it's 12, 12, 12, and we're trying to find the area of this triangle. The formula for the area of a triangle is half the base times the height, correct? Yeah, so let me slide this over here so we can talk about this, blow this up a little bit bigger. So if I want to find the area of this triangle, I already have the base is 12, but I need to find this height h. True?
Yeah.
Okay. You have a choice. You could use special right triangles. Because what kind of triangle is this here? This triangle is a right triangle, but it also has a 60-degree angle in it,
Yeah.
correct? So this angle must be what? 30? Everybody agree? So I could use the special 30, 60, 90. Agree?
Yeah.
Or we could use trig. Let's put it to a vote. How many people want to use 30, 60, 90? How many people want to use trig? We cannot use Pythagorean theorem because we only know one side
Can we just?
of a right triangle. You need to have two sides in order to use Pythagorean.
AC has to be 12 and CD would be 6.
Oh, that's true. Oh, dang.
Okay, I figured that.
Talk to him.
Where's my By the way, I really need some Pez loaded.
Oh,
I got that answer right. Next time, boys.
Tyler's gonna clap.
Oh.
Oh, that's cute.
Oh, it's
Nemo.
It's a Nemo Pez video.
No, it's not.
Video
It's
view.
Nemo.
Yellow.
Yeah.
Okay,
What else would it be? It's supposed to be-
all right, so yeah, so we can use 30, 60, 90, or we can use trig, or now that Connor has reminded us that this is gonna be 6 and this is gonna be 12, we could use Pythagorean theorem. What is your choice?
Pythagorean theorem.
High tag.
Pythagorean.
It's so easy.
We should really split it up and do like 1/3 here, 1/3.
Can we do the Pythagorean?
We want
I call it
Pythagorean
Pythagorean.
I'm already doing.
Let's use trig. I use, because we could practice what we just learned for the final.
We don't have.
You don't think that
Pythagorean, you're not.
I'm already halfway through solving.
All right, I tell you what, you pick your method, go. Pick your method, go use your skills, use one of these 3.
What do you want to do?
That's wait, it's the 12 pencil. What's up?
Does anyone feel like the answer?
I don't know how to get the answer.
Take your very brows, not the
Did you get like 10.39?
Exactly.
10.4.
Okay.
Around at the nearest.
I did that using trig. If I was gonna do 30, 60, 90, guess what, even easier, nobody wanted to do that. Did anybody do 30, 60, 90?
I can't remember that.
I don't remember.
Yeah, we know what that is.
30, 60, 90, if I'm trying to find the side opposite the 60, that's the long leg. Long leg equals short leg
Oh, no.
times
No, I don't remember.
square root of 3.
3 cubed.
Times square root of 3.
Oh,
Yeah.
So
Yeah.
then I would get long leg, which is our h, is equal to short leg, which is 6, times square root of 3. Boom, done. 6 square root of 3, which is the same as 10.39. And did you get that same thing using Pythagorean theorem?
Yep.
All right, so at this point, that's great, but we still didn't find the area. If this is 10.39, the area of the whole triangle, area of the triangle is going to be 1/2 the base. What's our base? 12, and our height? 10.39, and so that gives us what? On my calculator, I'm taking that times 12 times 0.5. Are you getting 62.35?
Yeah.
Yes, 62.35.
That's 62.3.
Yeah, if you do the 10.39 by itself, then it's just 62.34.
Would we get marked off for that?
Oh, gotcha. No, that's okay, because I was using all the digits that my calculator had stored, so that's fine. So you want to go with 62.34?
I don't care.
That's fine. And so at this point, 62.34 was the area of the triangle. Is that square inches?
Yeah.
Yes? I don't know why that says something weird. And then for step 3, I need to subtract. Slide this down. Subtracting. I didn't want to drag you down. I don't even know where you went. There you are. Sliding this down further. Okay, so now are we subtracting?
Yeah.
All right, what am I subtracting? 62.34. I'm subtracting that from what
Oh,
was
yeah. 75.4.
75.40. All right, and what does that leave us with?
13.4.
Area of the, it doesn't say area, does it? Area of the segment is going to be equal to the area of the sector minus the area of the triangle. What does it turn out to be?
13.06.
13.06, and is that inches squared? Are we okay with this? All right, not too bad. All right, let's take a look at,
No one said yes, you moved out.
are we good?
I'm so lost.
Run it back here a couple more seconds.
Okay, are we okay with the area of the sector?
Yeah.
Are we okay with the area of the triangle?
Yeah.
Yeah, we found the height using 3 different methods. We found the area of the triangle as half the base times the height. That's what I did right here.
Yeah.
And I got 62.34. But what are we really trying to find? We're trying to find the area of this segment, right, that shaded region. So I need to take the area of the sector minus the area of that triangle, and that will leave me with just that little sliver, just that little segment. All right, and that's what we did, and we got it to be 13.06.
Oh, I get it.
All right, let's take a look at arc length. Arc length is going to be a distance along an arc, and it's going to be measured in linear units. All right, this is not to be confused with arc measure. Arc length, arc measure, completely different things. All right, arc length is going to be, like if I was a little ant and I was right here and I wanted to walk around the circle, the arc length would be telling me how many inches I'm walking, or how many centimeters I'm walking, or how many miles I'm walking, depending on how the circle was measured, right? So I really am just looking for a fraction of the circumference, right? It's going to be a fraction of the circumference. And that's how we find the arc length, by taking the circumference formula, which is 2 pi r, and multiplying by what fraction of a circle we are walking around. All right? So I want this arc m degrees over 360, and then times the circumference of the entire circle, and the circumference formula is 2 pi r. Are we okay with this?
Yeah.
So it's 2 pi r times the fraction of the circle that we want. All right? Just like the area of a sector is a fraction of the area of a circle, and arc length is a fraction of the circumference of the circle. All right, let's put this into play.
Like, what's the, is it cubed or squared for linear?
It's linear units. So it's just inches, or it's just centimeters, or it's just miles, or it's just meters. All right, let's take a look. Warning. There is a difference, as I mentioned, between arc measure and arc length. Arc measure is equal to the measure of a central angle, and we write that as measure of, for example, measure of arc CD. All right. Arc length is the distance along an arc, and it's measured in linear units. And we would write that just as arc CD, and this is the one that has the special formula that we just talked about. Arc length formula is 2 pi r times the fraction of the circle that you're going around.
No, what's our measure?
It's the definition.
Arc measure,
Oh, linear unit.
for example, if this angle here, let's say this angle, the central angle measured 135 degrees, then, and let's say this is point A, this is point B, then the measure of this arc would be 135 degrees also, right? I would say measure of arc AB is 135 degrees. Agreed?
Yeah.
But if I want to find the length of arc AB, then I would need to know how far it is to get from here to here, right? That's what I would be trying to find, that distance in whatever units. Let's say this is, let's say this is 5 centimeters here. Now we can find the arc length, and that would be 2 pi times 5, right? 2 pi times the radius, times what fraction? What fraction of the circle do I want to cover if I'm trying to get from point B to point A?
135 over 360.
135 over 360. Are we okay with this? Does that make sense? All right, and we can get a decimal answer for this, and our answer would be some number of centimeters. Not centimeters squared, not centimeters cubed, just centimeters. All right, let's take a look at some examples. So in this case, We want to find the arc length, give your answer in terms of pi, and rounded to the nearest hundredth. If we want to find the length of arc CD, so here's arc CD right here, we want to know this distance. I'm a little ant, I'm crawling from point C to point D. I want to know how far do I have to walk? How many feet do I need to walk? Because the answer is going to be in terms of feet. So how am I going to get this arc length? Length of arc CD. What's our formula going to be? Carlina, can you help me out?
You're gonna have 2 times pi times radius, and then multiplied by 90 over 360.
All right, because the angle measure, the arc measure here is 90, and what is our radius here? So I get 2 times pi times 10 times, is it 90 over 360? Is that 1/4?
Yes.
All right, and so what does this turn out to be?
5
5 pi, what units would it be? Just feet. So if I was a little ant and I wanted to walk from point C to point D, I'd have to walk for 5 times pi feet. What is that to the nearest hundredth?
I don't.
Yeah.
15.71 feet. Are we okay with this? Questions on arc length?
There's one more.
Okay. Questions on this problem?
I'm not done yet, so.
That makes sense.
Okay, let's take a look at this one. It says find the arc length for an arc with a measure 35 degrees in a circle with radius 3 inches. Go ahead and talk about this with the people around you. How are you going to set this one up?
Yeah, that's pretty easy.
All right, so what did you get for this one? What did you do? Am I recording? I am recording. All right, Angelina.
Okay, I just plugged what we know into the formula. So,
Okay.
I did the arc length equals 2 times pi times the radius, which equals 3.
Okay.
And then parentheses, because you're multiplying, 35 divided by 360.
Okay. And what did this turn out to be?
I didn't finish that yet.
Okay. You're all plugging this in?
I'm done.
Yeah.
And what'd you get?
I don't know if I did this right. I got like a crazy decimal.
Crazy decimal. What's your crazy decimal?
It's like rounded 0.58.
On a 0.58. Are we doing 2 times pi times 3? I'm going to do 2 times pi I don't know why I'm doing it like that. Start again. 2 pi times 3 times, do I need my fraction? Is it 35 over 360? Is that correct? And I want a decimal approximation for this. I'm getting 1.83.
Yeah, that's what I got.
Are you agreeing on this? Does that look okay?
Yeah, I got
All right, 1.83. 1.83 in our units?
Inches.
Inches. And so that is how far a little ant would need to walk. If this was a 35-degree angle and this was 3 inches here, then this distance from here to here would be 1.83 inches. Are we okay with that?
Yeah.
All right. Okay. All right.
Even playing?
No, that's from like last year.
True that.
Yeah.
Okay. All right. So your homework is here.
Oh.
You are doing these problems from, oh boy, let's see. This is section 12.3. And you're going to do this worksheet as well.
We're like top 6.
Oh, we're talking about.
For us?
Yeah.
No, we're actually good. Yeah.
No, actually,
I didn't even get that. She won't give me more.
She doesn't have any left.
It's due
Friday.
Friday.
Rams.
I can, oh, sorry.
I can make you a copy of
Yeah,
I
I-
and then I can tell you fix the other stuff and you just put it on like the.
I have one copy.
Isabella, she
Yeah,
can
Okay, well, thank you.
All right, at this time,
Answer, excuse me. Okay. At this time, I'm gonna put you into groups to work on this worksheet together.
I'll send you tonight.
this is the one that's for homework. And let's see.
I don't have four rules, so we have one about like
All right, here we go. First group is Rachel, Maya, Nathan, and Ella. And if you guys can meet, I'll say right over by Ella. Next group is,
What's Nathan?
I'm sorry, Nathan Slattery. All right, next group is Olivia, Connor, Alex, and Andrew. And I'm gonna have you guys meet back by Andrew. Next group is Angelina and Nathan and Mitch and Isabella. And I'm gonna have you guys meet, I'll say, right up here by Nate May. And then my last group is Devin and Audrey and Carlina and, oh, hold up. All stop. All stop. Is that, oh no, okay, that's good. That's my last group. Devin, Audrey, and Carlina. Okay, you guys can be ready.
Can I ask another question? Did I pass 6.5?
Well, there's some stuff going. Let's see if it's been recorded and filed. This is block 2, 6.
Yeah, so this is fine.
Which one?
6.5.
You did pass 6.5.
You know what I got for you, Marker? That name. Okay, pass.
Just it's a pass. All right, so you're working on this.
I've lost working today. Wait, why does this desk? Because it's not locked. It's not locked. Yeah. There. Basically. I usually saw like 100. Oh, how much was yours?
No, you don't get it.
That would be. I just put it in ours.
Oh.
I don't.
I got 1.3.
This is.
Um,